Now we're going to go through different networking devices. And I talked about them when we were going through the OSI model, but now we're going to look at the actual functionality of the different devices themselves that are common on our networks. So a repeater, what layer did I say the repeater actually works at? That would be layer 1. We're talking about the OSI model, layer 1. And what happens at layer 1 is when the bits come down and they're put into some type of electricity. And so over like a copper wire, it's electrons that are moving back and forth. So at a repeater is not going to read any header information, it's not going to read any trailer information, it doesn't have any intelligence. All it does is it takes that the transmission and it amplifies it, which means it gives it more juice, you know, and then sends it on. And what I mean by gives it more juice is that when you have the, let's say, you know, let's say it's a copper wire, that's UTP, and you have these electrons that are going through the copper wire, what will happen is attenuation, which means the actual signal will start to degrade. So to be able to extend your network, you'll put repeaters there that will amplify the signal so it can get to its destination and be understood or be intact and not at a level of attenuation where the other computer can't understand it. So the repeater works at the physical layer. All it does is amplifies signals, and there's no decision making that it carries out. Now a hub is really a repeater. It just has more connections. Another name for a hub is a concentrator. And so a hub is where you have all of your computers or your devices connected to one thing, but this one thing has no intelligence. It's working at the physical layer also, and so it can't make a decision. It doesn't know when data comes in one port, what other port it needs to go out. So it actually just sends it out all ports. So when data comes in one port, it just sends that data to all the connections to it. Again, because it's working at the physical layer, which means it can't read any header information, which is instructions that will tell the devices where things need to go. Now a bridge is something that does not just work at the physical layer, it works at the data link layer. And it makes decisions on what port some type of data has to go to. So let's say that you have a bridge, you have a computer connected to one port, then it needs to go to this system over here. Well, the bridge will know by its MAC address which port to send it out. The bridge has a responsibility of really understanding on this port, port 1, these systems live there. Port 2, these systems live there. Port 3, these systems. And that's how it knows when it gets a packet or a frame which port it needs to go out. Now I said that it's making its decisions on the MAC address. And in this domain we covered IP versus MAC address earlier. But remember that the MAC address is a physical address. Your computer, the network stack, the IP address is at the network layer. A bridge works at the data link layer. It doesn't understand what's up here. So the bridge only understands the hardware address, and it makes decisions, forwarding decisions. That's what, and we say it's forwarding, where a router will route the data. Now, different bridges, the software in them, you can actually you can manually type out what systems are connected to what ports. Other bridges will basically come up empty within their actual forwarding table. They won't necessarily have all the systems. And what the bridge does is it sends out probes through its different ports and listens to what traffic actually comes back. And it'll start building its table of where things live on what port. And as an administrator, you set up forwarding tables, and you can do filtering, but based only on the MAC address, filtering based on that hardware address, not IP, because it's not working at the network layer. Now, we have bridges that can work at a higher level. today in our environment. Most of the time we use the switches, which we'll talk about, but for the exam, the bridge works at the data link layer, and really that is the main place that it works. It can have different types of products can have other functionalities, but the main place that it works is working with that MAC address at the data link layer. So what our networking environments have moved to is switches. We don't really use as much bridges anymore. We use switches, which the core of it works at the data link layer, where it's making decisions on the MAC address of which port to send it out. Now, the reason that we've moved from bridges to switches is that bridges will make its decision on which port to send it out in software, and the switches actually make its decision in hardware, which is always faster. So switches are much faster than bridges. And we're going to talk about another type of thing that switches bring to the network that bridges and other types of devices don't.